one person should give us a prayer as we start our lesson. One of you should do it for us, please.
Okay, let us pray. Let us pray. Lord Father, we come before Lord Jesus Christ, thanking you for today. We thank you for this time that you have given unto us, even as we go into this time, Father. Father, I pray for wisdom, knowledge, and understanding. Father, I pray that we shall put all what we are going to be taught into practice, and we shall be the teachers, Father. Father, I pray that we shall learn more and continue to put all what we are taught in practice. I pray all this in Jesus Christ our Lord. Amen.
Okay, thank you so much for that prayer. I'm going to share something here, so you will excuse me as I look for this document. Yes. Yeah. Now, in our last lesson, we discussed effects of forces, where we talked about what forces can do to a certain body, and we also looked at the difference between weight and mass. We saw different types of forces, and we classified them as either contact or non-contact forces. So after looking at those forces, I want us today by looking at what we call intermolecular forces, or forces that act between different molecules. So this is going to be our lesson today. By the end of the lesson, we are going to have discussed all the intermolecular forces. Now we have a question on our screen. If you are able to see that question, the question says that when washing glass utensils at home, water remains attached on the utensils. So the question is asking us that if we know the reason why. So they're asking us, do you know why water remains on utensils which are glass? So can someone talk to us? Maybe raise up your hand and give us the answer. If you are the host or co-host, you please help me with the people. Ariel, you are a host, if I'm not mistaken. So you can unmute and speak. It's okay.
Water sticks on so it remains attached on the utensils because of the adhesion forces between the utensil and the water. The strong adhesion forces.
Because of the adhesion forces. Okay, thank you, Ariel. Is there any other person who has an answer? Any other person who has an answer? Why you think this happens? Why does water stick on the walls of the glass?
There is no answer in the chat and no one raising.
Okay, if that's so, then according to what Ariel has told us, that it's because of the adhesion forces, I want us now to look at the adhesion forces themselves. So they are telling us that forces of attraction exist between molecules. So as we have molecules are those particles in a solid, maybe in a gas, maybe in a liquid. Now they are telling us that so if we have forces of attraction that exist between molecules, now these molecules can either be of the same kind means of the same type, or they can be of different types. So we have forces of attraction between molecules which are of the same type, and we also have forces of attraction between molecules of different types. In our books at school, we normally call them same kind or different kind. Now, these ones are either cohesion forces or adhesion forces. So we are going to look at what are these adhesion forces and what are these cohesion forces. Now, I want you to look at the text. If each of these dolls is a molecule, what do you say about the forces? So you look at the dolls that you are seeing. What do you see? What is the difference between the dolls in cohesion and the dolls in adhesion? Can anyone give us your view on that? We have two things. Two diagrams. Any person to share with us? What do you have to say about the diagram which has cohesion force and the diagram which has adhesion force?
Senegal Austin in the chat says that the dolls in cohesion are the same color. Then Faith says that the dolls in cohesion are the same, while the ones in adhesion are different. Cindy says that the dolls in cohesion are alike, yet those in adhesion are unlike. Yes.
Okay. Thank you for those answers that you have put in the chat.
Between those.
So if you look at the dolls in, yes, is there any person who has
Ariel says that dolls in cohesion are of the same kind, while those in adhesion are not of the same kind.
Okay. So we are going to continue now from this, and then we define. So I need someone to read for us the definition for cohesion and then the definition for adhesion. Anyone who can read for us?
Isaac Semicolon is raising his hand.
Okay, Isaac, you read for us.
Definitions. Cohesion force. Force of attraction between molecules of the same kind. E.g., rain falls in droplets because of strong cohesion forces of water molecules in air. Adhesion force. Force of attraction between molecules of different kind. For example, when you dip pepper in a cup of water, the pepper gets wet because of adhesion forces between water and pepper.
Okay, so we are learning that cohesion is the force of attraction between molecules of the same kind, and therefore it will keep things together if those things are of the same kind. For example, rain falling in droplets. Whereas adhesion force is the force of attraction between molecules of different kind, and they are telling us that when you dip pepper in cup of water, the paper gets wet because of adhesion forces. In other words, the water molecules and the paper molecules have been attracting each other. So the reason why water wets glass is because that is the scenario that we started with. Water wets the glass because the adhesion forces between water and glass molecules are greater. That means they are more than the cohesion forces that are between water molecules themselves. So the reason why you will find glass wet like that is because the water glass forces of attraction, which is adhesion of different kind, is greater than the force of attraction between the water molecules, which are of the same kind. So if a person asks you why you think water wets glass, you say that this is because there is greater adhesion force between water and glass molecules than there is cohesion force between the water molecules themselves. So there is a question that is on board, and I want you to write the answers in your chat. The question reads, why does mercury form spherical shaped droplets when poured on glass? So you put your answers in the chat. I'm giving you 5 minutes for that. Then we'll read through those answers one by one. All right, can someone read for us the answers in the chat? My fellow hosts.
In the chat. Okay.
It's okay, you can go ahead.
In the chat, Senoga Austin says because the adhesion force between mercury and the glass is greater than the cohesion force between the mercury molecules. Then Feta says due to surface tension. Primus says mercury has a force of adhesion less than the force of cohesion and hence prefers to stick to itself together rather than on the glass surface. Then I say the force of cohesion among mercury molecules is greater than that of adhesion between mercury molecules and glass molecules. Then Cindy says mercury has a higher cohesion force than adhesion, making the molecules to try to avoid staying apart. They gather up, and those spheres Faith says that the cohesive forces causes the liquid to pull inward, minimizing surface tension. Senoga Austin says the force of cohesion between the mercury molecules is greater than the cohesion force. Yeah, it is because of adhesion from Henry. Then Pearl Grace says that the cohesion force causes the liquid to pull inward, minimizing surface tension. And then Ariel says that mercury has a greater cohesion force than adhesion force. Therefore, it forms spherical droplets when poured on glass. Then Henry says again, the cohesion force is between molecules of the same substance, while the adhesion force is between molecules of different substances. Yeah, those are the ones in the chat.
Okay, thank you so much for reading for us. The main reason for this is about the forces that we have had, that the cohesion forces now in the mercury molecules is greater compared to other adhesion molecules, and that is what will cause mercury to form spherical shaped things when it is poured on glass. So we have an activity here. It is asking, telling us to look at the diagrams and explain why the meniscus has different shape in water and in mercury. Now, if someone talks about meniscus, this is what they mean. They're asking us why in water, the meniscus means that the boundary of where water stops is in that shape, whereas the one where mercury stops is in this shape. So that is what they want us to explain. What is the difference between why is the water like this, whereas mercury is the other way around, whereas mercury is like this. So water meniscus is in red, maculae meniscus is in yellow. They are asking us, why do you think it is like that? So what we are going to do, we are going to explain our answers also in the chat so that we can be able to keep those answers for us to read. Ariel, your hand is up.
Excuse
Is there
me,
any
teacher.
question? Yes. Yes.
Okay, Ariel had his hand up, but he put it down.
Okay. We are going to write our answers in the chat. Why do you think the meniscus of maculae is like that? And maculae one is the one I've put in yellow, whereas the water is the one I've put in red. If you can see my screen properly, I've tried to simplify the diagram that they gave us in the document. So you check and see. Then you tell me in the chat, why do you think the meniscus is like you see it there? So let us do that first. Rafa, your hand is up. What could be the problem? Okay, can someone read for us the answers in the chat so that we can discuss on those ones?
Okay. Senegal Austin say that there is more cohesion force than adhesion there is more cohesion force than adhesion, while in water there is more adhesion force than cohesion force. And I say that mercury forms an upward meniscus because it has a less adhesion force between its molecules and the walls of the glass, while water forms a downward meniscus because it has a higher cohesion force between its molecules and the glass walls. Then Cindy stated that I think the mercury is still on forming the spherical shape because of the cohesion, the molecules pile, yet water molecules are all over the glass, making kind of a sunken shape. Then Prima says that meniscus in water occurs when the molecules have a strong attraction to each other than to the container, hence forming a convex meniscus. Then Henry the prof said that I think due to Brownian motion, then Primus again said that meniscus in mercury occurs when the molecules have a stronger attraction to each other than the container, hence forming a convex meniscus. Then Paul Grace Gamba something said the mercury is still forming the spherical shape between the cohesion of the molecules while yet water molecules are all over the glass, making a sunken shape. Then Isaac Semacola said that for water, the force of adhesion between the water and the glass molecules is greater than the force of cohesion among the water molecules. So water clings to the glass, forming a concave meniscus. For mercury, on the other hand, the force of cohesion among mercury molecules and glass molecules, so mercury cling to each other, forming a convex meniscus. Yeah, that's it.
Okay, thank you for reading for us all those answers. Now, the reason for this would be that the reason that people gave, the one for water having more adhesion to the glass than to itself, it will be more attracted to the glass walls, and therefore it will form that downward meniscus, whereas mercury being that it has less attraction, it has less adhesion, but more cohesion. It will be attracted more toward itself, and it will make that upward meniscus. So the answers that you people have given us are so correct, and I really thank you for that. So we have talked about the intermolecular forces, cohesion, and adhesion. And after that, after looking at those ones, we are going to look at something else now, but also as part of forces. And that one is going to be friction of surfaces. So somewhere you write friction, and then we can discuss through friction. I will excuse me for some little time, and we see how we can discuss friction. Iza silaje waina ku mouse. Iza silaje waina ku mouse. Mouse. Asim, you come and help me. You go and tell Teacher Patrick to assist me with the mouse touchpad. Body yange esikundya
¿Qué la pasa? Romper de acá, sí.
مرة تانية.
Abalimi balagiddwa okukulembeza omutindo okusobola okuganyula mantuuyo zaabwe nga bazirima. Bino byogeddwa omukugu mu by'obusuubuzi n'ensimbi Hajji Jamiru Ssebalooni bw'anategeezezza nti Uganda erina obusobozi
So our teacher has gone off, but he will be returning in few minutes. I think his network is unstable. I mean, was unstable. Okay. So let us wait for him. He's almost back. Asha is almost back. So let us be patient. But we can still be making summaries of what we have learned about adhesion. I mean, intermolecular forces. Can go on making summaries and also be researching about the friction force as he returns.
Also, if you have a question you're not sure about, can discuss it as he comes back.
Exactly. You can raise up your hand and submit an answer.
Excuse me. I'm sorry I got off abruptly. The machine that I've been using, I think, has got problems, and I couldn't continue with the lesson. The good thing is that we had looked at the intermolecular forces, and what we are going into was now we are going to look at friction. I've been advised that if, because the time that we have now cannot allow us to do the friction and we complete it, so you will allow me close this lesson from here. For the little time that we have spent, I thank you for keeping around and for giving me a good time as we discussed through the intermolecular forces, but we cannot continue for long. So you will allow me stop this lesson from here, and if you don't have another lesson, we can all log out. Otherwise, I wish you a good evening and the rest of the day, of the week. Bye.
I think we can log out.